Yo, what's up guys? Great Forest here, back with another LeetCode solve, and today we're solving islands and treasure. I'll do this question in LeetCode, but it's like a locked paid question, but LeetCode got us with it, so we're good to go. Let's just approach this. So we're given an m by n 2D grid initialized with three possible values. Either a -1, which is a water cell that can't be traversed, 0, which is a treasure chest, or infinity, which I guess is this integer that is a land cell that can be traversed. And what we're trying to do is we're trying to fill each land cell with the distance to its nearest treasure chest. And if a land cell cannot reach a treasure chest, then the value should remain infinity. Assume the grid can only be traversed up, down, left, right, and modify in place. And we have this example here. Let's see if we can copy this down. So it's infinity, -1, 0, infinity, 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 -1, infinity, -1, infinity, -1, 0, -1, infinity, infinity. So I'm thinking there's two ways we can approach this. I mean, we need to override all of these land cells or decide that there's no way to reach a treasure from them, which means we can do this two ways. We can either start at a treasure chest and explore outwards. So then, like, if we were to linearly search this for the first treasure chest, we find this one, and then we can look in all the directions and update these values with 1, 1, get here 2, 2, 3, 4, and so on. Or I think another perfectly good way to solve this is to start on land and look for the nearest treasure. So I can't go this way because it's water, but I can go down, and right, I can go down and right again, and then I find this, then I'd know this 1, 2, 3, and then this can be 3. And even from my picture, maybe you can see that it might be more, I don't think it's asymptotically any more expensive to start from land, but it's definitely a little bit more complicated, and it would make sense in a normal problem that there'd be less treasure than land on average, so I'm going to go ahead and start with treasure. And I'm remembering now a big pitfall I fell in the last time I tried to solve this problem, because this isn't the first time. I was starting here, right, and I was kind of treating this like a backtracking problem, where I would explore out in one direction until I couldn't explore anymore. I would go out until obviously I can't go left here because of water, but I would try right, and then from here I'd be oh, I can't go anywhere. I would keep track of duplicates, then I could mark this one, and then I'd go down, 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 right. But what the backtracking solution does is it's really a depth first search under the hood, since you're doing it recursively. And that I ran into a very specific edge case with that, which I was just not expecting at the time. I don't know. Let me see if I can find it, because I think this is a good lesson. Yeah, here is this is the solution. I did this whole recording thing, I guess you can see a couple weeks ago, and I realized that this didn't work because there was a test case that was built. It accepts here on the normal test cases, those are all fine, but then when I submit it, this one gets me. Let me draw out this test case for you guys. Infinity, oh wow. Infinity, 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 -1, infinity, 0, infinity, infinity. So what I was doing was, like, I start here, and the first backtrack I have is like up 1, right 0, so I like go up. And then from here I can't go left and I can't go backwards, so I just go up again. And here, like, the only valid move I can make, because I had like a visited like list, so I couldn't go backwards at all. So I just kept traversing around like this until I like reached everything, and I would update this like 1, 2, 3, 4, 5, 6, 7. And you might think like, oh, that's right, but look at this right here. If I just went right at the beginning, this is supposed to be 1, not 7. With this, with the DFS approach, it just gives you the first thing that works, and there's no way to like non-deterministically go up and right using backtracking. And when I solved this a week ago, or when I tried to and then abandoned it, I was like, oh, I just need to do a DFS on each level at one time. And it's so stupid how, like, when you're in these problems you don't realize it, but the solution is not DFS, it's BFS. This is exactly what BFS is. It's not the one thing all around. I want to search this level by level, so then I can update both of these at the same time, and then just keep going. 2, 2, and then 3, 3. And I don't know how I didn't come up with that on the spot, but hopefully it's a lesson I learned and a mistake I won't make again. So I think the proper approach actually is to start on the treasures and perform a BFS outwards, because then I can, avoid the problem of having one deterministic way to like look at everything, but then never getting the path that's right there, And I think another thing that you can do is you can actually run the BFS from all the treasures at the same time, which I'll show you. It's just a nice little trick you can do with the frontier. So I think this will work, so let's hop right into it. First, I'm going to need to get rid of all of this, because it's not useful to me. And what is useful, I think we're going to need this still. Length of the grid and length of the 0th position, and we're going to want to loop through this again, so for iron range. So we still need to see if grid ij... Are these integers? Yeah. So if it's treasure, then I want to do something. Well, what do I want to do, actually? Let me think about this for a second. I want to add to my frontier. I need a frontier, which is a deck, I guess. So we can append... What do I want to append? The tuple to the frontier. And then we can go in while frontier. I think we should be able to do row column is frontier dot pop left. So that's giving us the position. We also want a visited set if continue. What is this? Why doesn't it like my... Oh. That's weird that I have to do that. So if we've already seen it, I don't want it again. But if we haven't seen it, then I want it. And then if not, I want to look through all the possible options of movement, which are these. And add them there. But then I actually have to do something. Wait, I'm not actually doing anything. What do I want to do? So I collect all of my treasure positions and like append them to my frontier. And then I think it's here. Because I visit. And then I want to update grid RC with what? I think I need a distance actually. Maybe I'll do that. So then I can get that. I'm still only gonna store the rows and columns in the visited because I don't need the distance there. But if the distance comes in, so what am I actually doing here? I'm putting all the treasures in. I pop a treasure. I add it to the visited list. I've seen the treasure. Now I want to update this with the distance that's there. And then when I go look at the next possible things, I want to traverse over there. And then I want to add one to the distance. Okay, this is looking pretty good now. So I go and I find all the treasures. I add them to my frontier. I do the BFS boilerplate, but I have a distance too. Treasure is obviously 0 distance from a treasure, so I put 0 first. I see whether I've visited it before, because I don't want to be able to go backwards. I don't think you're allowed to do that. And then, oh, well, not that I don't think you're allowed to do it, it's just that would cause loops, which is not good. Then I want to update that position with the distance, and this would catch even the treasure cases, because this will have to compute treasures as well, because the distance on the treasure is 0, and it's already 0 there, so that'll be fine. Oh, I need to catch waters as well. Maybe I can do it here if here grid r plus dr c plus dc. There's probably a few places I can catch it, but this seems nice. Well, only if it's not that, then I want to append. If it's a water, then I can't do it, so I don't want to even search that. I think this will work now, because then I like look at all of those. Tuple expected at most. What? Is it really that? Oh, I need to check the out of bounds condition too. So if, or should I do that up here? Maybe I'll do it up here. I can go like if, or I can do it here actually. If it's greater than n or less than equal to 0, or no, it's allowed to be 0. It's allowed to be n, or no, it's not allowed to be n, so it's this. Or that, or that, or that. And then I can get rid of this. So I can just catch them all in one condition instantly. This is a bit long, but that's fine. Okay, that works. Well, let's see if it passes every test. Beautiful. Wow. I'm surprised. I actually didn't re-look at the solution. I don't know. I've solved this once, and I attempted it another time later, and I couldn't do it. Um, Pretty cool. I didn't even look at the BFS boilerplate before this. I haven't really done LeetCode in like a week. So that's pretty awesome. Last time I did this, I just copied the LeetCode solution pretty hard. Yeah, he does it all down here. But this makes a bit more sense in my head. I just always append everything, but then if I see it, I'll instant return. Maybe this is slightly faster, but I doubt it matters. Okay. Until next time, thank you for watching. Like and subscribe. Bye.